Hello everyone, in this video we'll be solving problem 148 sort list. The problem statement is we are given the head of a linked list. We need to return the list after sorting it in ascending order. In example number 1, the linked list is in the format 4, 2, 1 and 3, and after sorting it in ascending, the output should look something like this, starting with node 1 all the way to 4. The problem statement is very easy to understand and there are multiple approaches we can use to solve this. Let's switch to whiteboard and discuss a couple of them, starting with the naive or a brute force approach, following up with an optimized one. Starting with the brute force approach, we'll start traversing through all of the nodes in the given linked list, save it in a collection, sort the collection in the ascending order, and then rebuild the linked list using the sorted array. This solution gives us the time complexity of O of n, where n is the number of nodes in the given linked list and space complexity is O of n as well, as we are maintaining this collection with all of the values of the nodes and then sorting it. This is one way of solving the problem. Now let's discuss an optimized way to solve this using divide and conquer and merge sort. The idea is to break this entire problem down into smaller problems, solve them separately, and combine them to build our solution. And because the problem statement is asking us to sort in ascending order, we will use the merge sort algorithm because it gives us the time complexity of O of log n. If you're not familiar with the merge sort algorithm, let's quickly discuss how it works. Let's say we have an array with these items in it, 5, 3, 4, 1. The idea of the merge sort is to split them up into halves and then solve them separately. For example, with an array size of 4, we'll split it up into two sections, 5 and 3, and the other section will have 4 and 1. Now we'll split this as well into more smaller pieces or granular pieces. So we'll split 5 and 3 and 4 and 1 separately. So now we have 4 separate elements, 5, 3, 4, 1. We'll keep splitting them up until we have individual elements. Now we'll start processing each element, that is, build the sorted array. And we'll do that by comparing two adjacent values. We'll start by comparing 5 and 3 and sort them in ascending order. It is easier to compare two numbers and put them in the correct ascending order. So between 5 and 3, the sorted order would be 3, 5, and similarly we'll do for 4 and 1. So the sorted order will be 1 and 4. Now that we have two collections, we'll combine these two and do the same operation. After merging the two subarrays, my output will look something like this, which will have 1, 3, 4 and 5. This is how merge sort works. At each level, we were processing all of the elements in the array, which gives us the time complexity of O of n, where n is the number of elements in the array. And as we are splitting the array by half every time we are dividing and then merging using the similar but reverse operation, the number of levels can be calculated by log n. So multiplying the two together gives us the time complexity of O of n log n. If we consider this input as an array, we can directly apply the merge sort algorithm and start building our sorted list. But the only caveat or challenging part here is it is a linked list. Each node is actually connected with the next node in the list. So when we are building or breaking down the entire list into individual nodes, we need to terminate this connection so that we can build it with the correct sequence. And the second part here is if we have an odd number of nodes, it is difficult to identify where to break it into two smaller chunks. So here, because we have 5 nodes in the array, we'll consider the first subset with 3 nodes and the second one with the 2. So when we break this down, my left hand side would have -1, 5 and 3. As we are splitting the list node at node 3, its next node needs to be updated to null instead of pointing to 4. And similarly, we'll keep on breaking it down into smaller nodes. And once we have all of the individual nodes identified, we'll start rebuilding them. With this solution, our time complexity is O of n log n, as we are using the merge sort algorithm to rebuild the entire linked list, while the space complexity is O of 1, as we are rebuilding the entire sorted array on the fly and not maintaining any additional collection. I hope you were able to understand the explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by adding a couple of basic checks on the input. After that, I'm calling the getMiddle method that uses the slow pointer fast pointer approach to calculate the middle of the list node. Once identified, I'm creating two variables left and right and updating the middle.next with null so that the two halves are disconnected from each other. After that, I'm calling the sortList method again recursively to pass the left and the right halves of the list node and expect it to return me the sorted form. Once both the left and the right halves are sorted, I'm calling the merge method, which will take care of merging the two together into a single list node while making sure they are sorted. The merge method uses the two pointers approach to point at both left and the right node, compare the corresponding node's value with each other, and accordingly build the output node in the sorted form. Once we have iterated through all of the nodes in both of the list, that is the left and the right pointers are pointing at null, the iteration stops and it returns the sorted list as an output. This code, when submitted on LeetCode, beats 53% of the submissions in terms of runtime and 56% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details about the source code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.